Hi, I'm Naz. I'm the CEO and founder of Rebel and the author of Developer Life and maintainer of the Rebel, Dewey Crates. I believe that open source comes from an open heart and from the joy of coding. In today's video, we're going to talk about Rust polymorphism. I actually have a couple of videos that and a couple articles on Developer Life I've done so far. One was on the type state pattern. That was actually quite popular on YouTube. And then recently I did another one on the new type design pattern, which was it's also proving to be quite popular. So I decided to follow on with this one. I've been meaning to make this for a while now. A couple of months ago, I did this Lifetimes video and article, and I talked about subtyping and variants. And one of the things, like if you're coming from an object-oriented background, then Rust can seem a little bit restrictive in many ways because it expects ultra concrete types and generics. It monomorphizes, and so you can downcast references and things like that, but it's a bit cumbersome than probably other languages that are object oriented, let's say, because in Rust there's no cost abstractions, so there's no garbage collection, and there's other benefits for there's a trade-off. Having said that, though, in today's example, I wanted to give unfortunately most of the examples, and I'm also at fault for doing this, but I did the cat, dog, and animal whatever example, which I don't know. It's kind of like it's not that good. I don't like it. So I'm gonna actually update this after this video. But so today, in today's video, I'm gonna do an actual example, like a real world example of using polymorphism to model something that you would find in very common, like Android view hierarchy, or like React components or something like that, like some object-oriented system where you have some user interface library, and that user interface library has this concept of a view, like in a browser. You can have like the DOM where there's nodes, but then there's buttons, and the button is a subclass of node, and then in Android there's views, where there's like the top level class called view, and then you can subclass that, and you can make like a button or something like that. So I wanted to model something like that in Rust and show how we could implement that polymorphism in Rust. But since there is no inheritance per se, like what we're going to be using is subtyping, and specifically traits, so trait subtypes. So these are all really good videos to, actually this one. What we're going to cover today will actually kind of touch upon this as well. It's related to this, the new type design pattern. And then, yeah, and these are all good. The subtyping variants video is good to want to watch. Oh, actually, I already had that open. And then so is this Lifetime's article on developerlife.com. And also related to that is type state design pattern for sort of a more complex way of modeling polymorphism. So let's see, with that said, let us get to our live coding example. So let's see, one thing I want to do is, first of all, let me create a new crate. I'm going to call that polymorphism, and then let's open it up in Code Insiders. Polymorphism. Oops. Okay, great. And then let's close this. We don't need this anymore. Okay, so let's see. The first thing we're going to do is let's make a new file. You know what? I can actually do the whole thing here as actually, I'm just going to dump it on librs. Like, there's no reason to. It's just going to be one example. I don't think this video is going to be that big. So let's see. So at the most basic level, the thing. Let's do this. We're going to create some concrete types, recursive. And so what we want to do here is we want to create a view. A view is going to have dimensions. So it'll have like like sizing and positioning. So essentially there's going to be a width and a height and an x and y position, which is what a view is. It contains that information. And then we're going to create something called a component, which is a view, but it also has an added capability, which is that it can render itself. And so this is the example of that sort of hierarchy where you can have like a button that's a view, but you can also have a label that's a view, or a text field that's a view, and so on. So let's start from the bottom up, and let's create these width and height. So because we learned from the new type video here that instead of using U sizes all over the place, it's nice to have, actually let's leave some custom types. So we can have like one called width, which just wraps around a U size. Then we can have a height, and I think we need a couple of derives for this. We need, because we're going to write some tests. So we need, yeah, that sounds good. Let me just copy this here. So we got width, height, then we're going to have a x position. So we're going to do x, which is this, and we're going to do a y. And same thing, let's just grab those derives. Okay, so now we have the, oh, let me zoom in. There we go, that's better. So now we have the most basic building blocks of what we're going to represent using our polymorphic design. So let's make, using these base types, let's kind of build up and make a, like, I'm going to call it dimension. Actually, let's call it, it's like dimens. So dimens 2D, like dimension 2D, where the struct has a width and a height, and it has an x and a y. So far so good. Nothing really even remotely interesting at this point. So here we just have, using the new type pattern, I'm stubbing out some of the things I'll be using in a minute. So then now I'm going to jump right into the traits and the subtyping. So let's do traits. So the first thing we're going to have is a trait that is a view. And the view is going to, let's say in this case, I'm actually going to make this example a little bit somewhat needlessly complicated because I wanted to incorporate generics as well. But so here, the view we can literally just have a view where we can say something like get dimens, and that returns a dimens 2D, and we can have set dimens, and that returns a dimens 2D. So, but since this is all about traits and polymorphism, what if we wanted to abstract dimens 2D out of this for whatever reason? Since maybe we have a dimens 3D, or maybe we have some other kind of dimens. So so let's do this. So we can replace it with t, and we can say, okay, if you take a view of type t, then you can, t is the generic argument that you have to pass, and dimens 2D would be that. So what if we further restrict its bounds, just to kind of show the syntax of, like, because this is prep, like we're going to do this with view in just a moment. So I just wanted to show this happening with other traits. So we can say that the view can be generic over any t as long as that t is clone and copy. Let's just take out partially. Actually, we could do this because if you noticed, all of these have that. In fact, I could go even further. I could say debug. So these trait bounds essentially, oh, actually this I need to import. No, what's the problem? Yes. Okay, let's do that. I wonder what debug it was importing. There we go. Okay, so so here, essentially, I've taken this whole our derived block and just put it here. But this is just to show that here I'm using trait bounds, and the trait bounds here essentially say that the view could be generic over any t as long as a t satisfies these trait bounds, which means that t has to implement debug, copy, clone, partial EQ, and EQ, which is fine. So somewhat arbitrary, but kind of like just to kind of introduce that syntax. So view has x, y, width, and height. So in this case, I've made it generic over t. So if I don't want dimens 2D, I can make some other kind of dimens, and I can have a view that's generic over whatever that, like for example, I can make abstract dimens 2D alt, where I can have like view sizes for, you know, whatever. And then let's make a test real quick. Actually, let's just write a test inline. So here, let's just say fn test view, and here what we can do is something along the lines of, let's say I wanted to make a dimens 2D, it would be one of these. If I wanted to make dimens 2D alt, it would be one of those. And then now I can create a view, basically. So let's just say, so the thing is I haven't implemented the, let's do this. I haven't made anything that implements this view. So what we can do is we could just say, let's see, we can do something like, actually we can't. So I need to make an implementation of this before I can continue with this example. So let's just table this for now, and we'll come back to it in a minute. Okay, so what would the let's actually do this dimens 2D. We'll say something like this, to do yeah, exactly, for dimens 2D and dimens 2D alt. Okay. So here, actually, you know what? Let me just take out this dimens 2D alt for now, because we'll come back to this later. So let's just, well, this is not that interesting. I can make a dimens, but I don't have anything that implements this trait. So, and this trait doesn't have any default implementation, so we can't really do anything with it, except for mark something as a trait bound to take this. So here, I guess we could do something like this. This is kind of, actually, let's just bring back, this is totally, like this won't do anything, but 2D alt, we can do something like this. Use size, and so here I can say something like, let's just ditch this for now. We can say something like pub type foo equals view over dimens 2D, and I can say view over dimens 2D. Oh, and this is din. Expected type. Oh, I don't think this works. Oh. So that's not a thing either. Let's see, type of view dimens 2D. Oh. No. Din. Expected a type found a trait. Oh. Right, because it's not. Okay, so what I'm trying to do is not going to be possible without first creating a concrete implementation of this trait. I was trying to do something that was not possible. I was trying to make like get the compiler to compile something that wasn't going to compile. So okay, so aborting that, let's continue with creating this. Essentially, this, you can consider this to be the superclass if we were talking object orientation. So you can think about, okay, what if I want a subclass that inherits from this? That means it has all of the things a view has, but it's got more. So then I can say that can be my component trait, where this is completely redundant, where I can say I have a render function which just takes self. That means when I render it, actually I can do something like this, and I can return a string. If we wanted to get even more complex, we could do O, which can be like, you know, debug and clone or something, and then we can say O. But now, in this particular case, whatever this output type is, it has to be specified in the component, which is fine. That's not a problem. So here we have two traits. The view, you can get and set the dements, and the dements can be anything that implements debug, copy, clone, partially queue, and so on. We could even make another trait which dements 2D and dements 2D alt implement. So I can say something like a trait which has a dements trait which has a width, height, x and y, but that's just getting too complicated. But this is just to show trait bounds, and this is just to show that like component does this. But notice that there is no relationship between right now between the component and the view. So we want that superclass subclass relationship, and the way to do that is that we can then say this trait, there we go, has that trait bound where all of this stuff has to be essentially this is all of this. T has to do all of this, and T also has to implement view. So I'm sorry, component has to implement view. So basically we're saying the component trait, which I could like, now I regret typing all this out, because you can almost like think of it this way. So component of something, actually that's not right. This would be O, so this is O. You can almost think of it that way, where this is not gonna, it's saying that your trait bounds are not satisfied because I put all this stuff in here. So, but yeah, so essentially that's what we're doing here with this syntax, is that we're saying that the component is a subtype of this other trait, and the super trait, this would be the super trait, and this is the sub trait. And you can see a relationship similar to this with copy and clone. I think copy, let's see, yeah, see the copy is the subtrait and clone is a super trait. So that kind of sort of like what we did, but much more noisy with a lot more generics and trait bounds. Okay, so we have a super trait and we have a subtrait, and then we have a bunch of concrete types. So not so far so good. So then now what we can do is, because the subtrait, which is component, inherits from view, it's not really inherits, is a subtype of the view type, the view supertype, or the super trait, sorry, not type. Now that the component is subtype of the view trait, what we can do is, this is super, here we can do something like this. We can make another trait like component alt, where it has a render function just like this one, but I can do some other needless things. I can say something like, I want to access this whatever self is, whoever implements component alt, I want to almost like downcast them and access them as if they were a view. So I can do that because I know that a component alt is a view. So I can create a function, a method that takes self and returns a type view. So this is, and it's that, check, this is that ampersand din basically. So this is for sizing reasons, but you essentially, what we're saying is that, okay, I have a thing that's a component alt, but if I wanted to, I could also access it as a view. And you can also access the mutable view. So you can say something like, as view mute, get a mutable reference. So basically you're saying that, okay, I'm a component alt, and somebody wants to access me, the component alt, whoever implements a trait, as if I was a mutable view. So that can be done. But this is redundant. We're not gonna, this is redundant because these two we actually get that because that's what this means. That's the subtrait part. So that's why we're not going to implement this, but I just wanted to show that if you wanted, you could write things out like this. That's totally that's valid in the type system. So now let's actually implement. So let's do some trait implementations. So actually, let's do this. Put some dashes around here. So like this. And here we have some concrete types. Okay. So for trait implementations, what we're going to do is let's make two structs. Let's make a button. Actually, why not? Let's just make a button, and we're going to make a label. So now this is just a module, and inside this module, for the button, what I'm going to do is I'm going to create a struct called button2d, and it's going to take it's going to contain a dimens. I'm setting it up so that we can implement the traits for the struct. And then because it's set up this way, now we can essentially implement those traits, two traits, component trait and view trait. Just ignore this redundant component alt. Actually, let me just hide this. So, okay. So now we have, we're going to implement view of, and we're going to say that this is dimens 2D. This is a bit noisy because I'm not really passing dimens 2D down into, I mean, technically we could do something like this, but that would be like this, and then kind of keep going. But then I just wanted to like not do that. Just kind of stop with this passing the generics everywhere. Kind of constrain it to just to kind of prove the point that okay, we have trait bounds. That was the only intention, just to introduce this trait bound. So here we're going to say something like, okay, we have a view of which is generic over the concrete type dimens 2D, and then we're going to implement the get dimens and the set dimens methods from the button 2D for button 2D from the from the view trait. That's how all these three different things came together. So far so good, and that was a lot of setup for not much code. And here we have like we're going to implement a component for a dimens 2D. That's the for whatever reason I made this generic, and it's going to return a string when it's rendered, and it's going to do that for button 2D, and it just basically just dumps this. It goes button 2D with height x and y. Okay. So far so good. So let's do something like this for label, where it's going to look almost exactly the same, where we're going to say we have a label 2D, which contains a dimens 2D, and it implements both view and component. And for component, instead of returning button 2D blah blah blah, it says label 2D blah blah blah. So it's a bit of a made-up example, but it's meant to show the relationship between the view trait, the component trait for a particular struct, and then the same thing for another struct, and then showing how the relationship between view and component is specified. That's this the subtyping thing. So, oh, where are we? Yeah. And then, so let's see this. So we have, let's see. So we got the label done, we got the button done, and now for more type system fun, let's do this. Let's make some functions that operate specifically on the subtypes. So functions that work with the subtrait type. But I'm just gonna, and then we're gonna have functions that work with the supertrait. Okay. So the subtrait in this case is component, and the supertrait is view. So let's do that backwards. So we can do the sort of the view stuff first, and then we can do this is view, and the subtrait is the component. So, and these are just to show the signatures of the functions, just so that to get comfortable with the type system and how it handles all these things. So here we can say something like pubfn component render, and essentially it's saying that there's a function called component render. It takes a t and an o. These are two generic type arguments, and the argument, let's say, is something that essentially, this is we have monomorphization or static dispatch and dynamic dispatch, and so this is dynamic dispatch. So essentially we're saying that whatever this is, it's a reference to something that implements a trait, and we don't know what the size of that is, so because that's the din keyword. And so so this is dynamic dispatch, not monomorphization or static dispatch, which would be like impl or something along these lines. So okay, so here actually this works too. So, but just to kind of keep things consistent in this example, or maybe I'll do one like this, I'll do another one with impl. Okay, so here we have like if I pass an argument that implements this component trait, this function is able to receive it. So if I do something like component get size, so check this out. So I can say that if my component is to, oops, what is going on? Oh, that's because it's missing. Basically, you have to copy this type signature everywhere, because in Rust it's at the function level, like you have to like repeat yourself so the compiler can match things up. Okay, so here it's the same thing as component render, but the difference, so I'm receiving an argument whose type is anything that implements a component trait, but I turn around and I call get dimensions on it, which is implemented by the view trait. So, and furthermore, I can do something like this, and that also works. This is dynamic dispatch, and this is static dispatch or monomorphization. So this is virtual tables and a vtable to do this lookup at runtime, and this is statically done at compile time. So, but it's equivalent. I mean, it does the same thing. So let's make another function for set size, where here I am receiving an argument whose type essentially is anything that implements a component trait, but I can call set dimensions on it. And if you recall, set dimensions is a method that we had set on the view trait. So I'm not treating this argument, which is a component, as if it's a view. I'm treating this argument, which is a component, as if it's a view. And here I'm using the argument, which is a component, as a component. So this is an example of like receiving arguments of different types, and then how the components can kind of be like, you can receive an argument which is a component, and you know that it's a view. But if you receive a component that's a view, you know it's not an argument, which is what we're going to see next. So this is the, I'm sorry, when you receive a view, you know it's not a component. So that argument, view argument, is not a component. So let's do this. So we can do, this will be something like, oh wait, the supertrait. I think I wrote this backwards. Yeah, totally. Oops. It's supposed to be there. Yeah, okay. So, yeah, the subtrait is, let's see, where did we define these things? Yeah, the subtrait is component because component has this colon view, which means this is a subtrait and that's a supertrait. Oops. Yeah, I sorry, I put the labels backwards. But yeah, this is still valid. I mean, so it's essentially if I get a component, I can treat the component as if it was a view. But if I receive a view, I cannot treat it as if it's a component because of the subtyping relationship. So, so you can think of it as like a component is a more specialized view. That means all components are views, but not all views are components. And then we implement component as well for particular structs. So that's how we get that polymorphism. So these functions will work whether I give it, in this case, label 2D or button 2D. And we'll see that in the tests below. So this is just kind of seeding. We're going to write a bunch of tests to see how actually, this is like we're defining the functions, and then we're going to see how calling them, using them, what that actually looks and feels like. So here we have the only actually, wait a minute, where's render? Okay, so this one, view only has, if we look at view, I think set dimensions and get dimensions. Yeah, it only has setter and getter. So here we're going to say view, we're going to say get size, and we're just going to take something that implements a view trait, and then all we can do with that is just call get dimensions, and then we can do view set size, oops, view set size, and yeah, there we go. What we cannot do, we cannot have view render. That's a no-go. This is not going to compile. Well, what Copilot did is it sneakily did that, but if you see, it doesn't work. View doesn't need the string because there is no render. See, the render function, the render method has an extra type which view doesn't need. If you noticed, like if you look at the view stuff, we didn't have to specify the output type. We only have to specify the T in this case. These are terribly named. I should have made this like inner T and output or something, or rendered output. But yeah, so as you can see, the type system is already preventing us from doing something that's not possible. Like we cannot call render nor view. View also doesn't need all of this. So if we copied this signature, view dimension, like it doesn't even need. Yeah, this is pretty straightforward actually. So actually we could do something like. Actually, you know what? Let's see. If I were to kind of mimic this style, so we would do something like that. And then instead of taking the dimensions 2D, and as you can see, it's complaining, but actually, let's just ditch these. These are just noise. It's complaining because we don't need this O thing. And let's see, expected struct dimensions 2D. Oh, oops, this should be T, sorry, got confused. So let's do, okay, so this is saying that this is more like written in this style where we're not tying it to dimensions 2D. So that's the thing. To make Rust more polymorphic, arguably it's more verbose and somewhat confusing, especially if you're coming from something like Kotlin or Java or TypeScript. Definitely, this is a lot more work, as you can see, but all that work is so that we don't use dimens 2D, all this stuff. But we can continue. We can say, view set size in that same style. And here, it kind of, unfortunately, gets a little bit more confusing, because now, I mean, you can do like here we did, you can say impl, so you don't have to use this din, so it's monomorphized. So yeah, there, it's not like super straightforward. Unfortunately, there's a bit of like there's a lot of like syntax, I guess, to look at, but I guess it is what it is. So here, if we did view render, we could, if we wanted to get rid of dimens 2D, because that's a concrete type, we could do something like that. But this won't work, because even if we did like this, because render method is not implemented for the view trait, so thus we cannot really, this is not a thing that we can do. So there you go. I'm just gonna take it out because this is just weird. But yeah, so that's an example of like the type system saying, okay, even if you kind of generify this dimens 2D, you still can't call render on a view. So regardless of what the T and the O is. So that's what this actually, I'm gonna leave it in there. Why not? We're not doing anything with arg anyway. Okay, so this is like functions which receive arguments of those, the subtrait or the supertrait, and what we can and cannot do with them. So with that done, let us write some tests. So this is going to be mod tests. Use super. Actually, did I write a test already? No. Okay. So in these tests, let's make like some defaults. So we're going to say something like, we're going to make something called small, which is a dimens 2D, and we're going to say it's 100, 50, oops, what is this, and 10, whatever, 20, and then we're going to have const large, which is also going to be a dimens 2D, and this is going to be 200, 100, 30, 40. Perfect. So, okay, we have some defaults that we created because we're going to write a bunch of tests. So let's start with the those subtrait functions that we had, these things. Let's exercise them. So this is the, we can say mod, pub mod sub trait functions, and oops, use super. Okay, don't know what that is. Okay, there we go. And here we can do similar thing. We're gonna say super trait functions, and we're gonna do something like that. Okay. Oh my goodness. Okay, perfect. So now we have subtrait and supertrait functions. Let's see. Yeah, that looks good. And then we're gonna exercise, because I get confused with the which is which. So now it's in a module, and so cannot get that confused again. So the super is view, the sub is component, sub, super. Perfect. I should have done the modules to begin with to keep from getting confused. All right, so now we're going to do a test on the, let's do the subtrait functions. So this is using, where is it? These things, the subtrait. So component, and so component can do more. The subtrait can do more than the supertrait. The supertrait can do less. I mistake, like the super is super, can do more, but actually no. Super means ancestor. Think of it like evolution and how like our ancestors crawled out of the ocean. So they didn't have rust, we do. So they're the super, we're the sub. The sub has more things it can do than the super. Yeah. Anyway, so so in the subtrait, let's do this. Let us pull in the. Actually, what are we pulling in? We gotta pull in the. Actually, let's do this. Let's make a button component, and that's gonna be a button. Yep, that's right. Dimension small, because essentially just wrapping small. So we're gonna make a button, and we're gonna make a label. Label, because we need something to pass to those functions from here. Yeah, so this is, and then we can do something like this: component render, which we know we can do because I think, oh, it's comp render. Oops. And let's import this. What the heck? Let's qualify it. So, so we're saying that, okay, we're pulling in component render from the subtrait functions, and we're passing to it a button component, which is totally cool. We can do that. We can then do the same thing to label component. So now we can render a button and we can render a label. This is just a very strange way of writing it, but just to kind of, actually, why are these mutable? Okay, so then when these are rendered, it returns an O, so we can say output one. Oh, actually, button. We can say button output is a string, and we can say what is this? Label output is that, whatever. And then we can say something like, actually, we could see print button output. Actually, we don't need to say button output. We can just do button output. Button, oops. Button output, and we can say label output. And then let's just see what this looks like. So the button is a button with a width and a height of 150. Actually, this is a mistake. This should be medium. I want to be able to tell them apart. So actually, it's large, I think. Oops. There we go. Oh, dang. Okay. So now when you run it, you can see one of them is a button with some width and height, and a label with a bigger width and height. So something like that. Okay. So that makes sense. And then, so we can do like, since the button just has a dimension in it, we can get dimensions. So we can say something like assert EQ. We can say button component, get dimensions is small, and the other one is large, because that's, yeah, passes, no problem. So yeah, this is an example of using the subtrait, the function that takes the subtrait as an argument, and then just basically turning around and calling the render method on it. So now let's do the same thing with, we're just kind of going through all the different types of syntax that we might encounter when using super and subtraits. So here's an example where we just take, actually, what is this? View set size. No, let's do this. Let button size, let's do get size. So here I'm doing a similar kind of thing. I'm just making like, I don't know why it keeps making them mutable. Let's just do this. There we go. So we have a button component. Button 2D. Get size. Okay. Then we have label size. Actually, because this one took an impl. So I'm not being very careful with, like here I just like took ownership of the thing and I didn't, and it doesn't matter because they all implement the copy trait, but let's just ignore that for now because that's not really what the specifics are. But yeah, if I were to make them equivalent, this should be ampersand because all the other ones are ampersand din. So, but you know what? I'll leave it that way. Okay, so I got I was able to call the view function the functions to take the supertrait as an argument, and then same thing for, so I can use a button. This is a concrete type, a button or a label. They're both views. Notice they're also components. And so I can then do like an assertion. I can say button size is small, label size is large, and that should just work. There you go. Nothing that interesting there. And this, notice I cannot render. Because, I mean, well, I cannot render, meaning that I can't, well, okay, if I call this, it's going to panic. So I'm not going to do that. But if we did something like this, and we called view render, this is nonsensical. This should not work. And why is it? Oh, because I've already, no, debug. Oh, what? View render. Oh. Oh my goodness, something like that. You know what? I'm just gonna comment this out. This code makes no sense. But there we go. Now I'm trying to do something that the compiler is like, you can't do that. I'm like trying to do that. It's just that was an exercise in futility. Compiler did its job. Okay, so so these are the functions. Now let's say that instead I wanted to access like, instead of using those functions, let's just make another test. And here we can say, so we're going to say access component as view. So here, so let's say we make a button component, we make a label component, and then we can do this. We can take the button component. Actually, let's do this. Let's make them both small. And then I can just call on the button component, I can call setDimens, and setDimens is actually a method on the view trait. And since button component implements both view and component, I can just treat this exactly like it was a view. And I can do an assertion, and that should be true. There you go. And then if I can, obviously I can render it just like before, so I can just say something like let button output equals that, and let's say label output, and I can print line this, print line that, and you will see that that's what they look like. They're both the same, have the same dimens 2D, because I set them both to large. So this is another way of using like kind of polymorphism in action, where I'm not actually, why have I done this? This is not at all what I intended to do. Wow, you really got to check output from this thing. What I want to do is I want to say render. That is what I want to do. And let's get rid of these. Okay, so oops, this is what I intended to do. I mean, the output is the same, but I don't want to use those helper functions or whatever, those functions that we created. I just want to like make a button, make a label. I want to call, and these are like view trait methods. And this is component trait methods. And this is just showing that we can, a component is a view. TLDR, because the component is the subtype and the view is the supertype. And so one last thing I want to show is like where you would even like there's many use cases in a view hierarchy where you have a bunch of components, you know, like you have a bunch of views and you want to put them all in the same vec or some sort of collection. So what would the type of that collection be? Like, how do you handle that situation? So let's take a crack at this. So this is a very common thing where we want to do accumulate components in collection. So let's see. So let's make a vec. A vec of what though? So we need a vec of something which will hold button components and label components, let's say. So, and we know that the component trait is component, and then we can say demands 2D, like that, but then, and then we need to put the din in there, which is, and now this takes 2, so we put string. And then what this is saying is that, well, I don't know what the size of that is. So what I'm going to do is, instead of, so I kind of put that, I kind of sneak that in very quickly. So I don't want to, so that's not going to work either, because this is not a variable. It's a generic argument. So this doesn't work. It's saying, I don't know the size. So what I'm saying is that, okay, I don't know the size of this, whatever it is, some struct that implements this component trait, which also means it implements view trait, which takes this as the inner storage and this as the rendered output. I'm like, okay, I don't know the size of this because it could be anything. It could be a button, it could be a label, whatever. It could be something else. Compiler doesn't know. By putting %mute, it means okay. So if I put ampersand, it means, oh, okay, cool. The reference to this thing is sized. And if you want to know about references and sizes, this is a really good article. I know it's kind of irrelevant because this says smart pointers for the kernel, but this actually does a pretty good job. This article, I'll link in the references, talking about like what a smart pointer is, like what extra information does it hold, and what are the differences. You know, like can you make your own like box, stuff like that. And so yeah, this is a good good read for smart pointers. So and I actually have a bunch of videos and articles on this as well. Where is it? Anyway, in there somewhere. So it's in the videos and articles. So okay, so here, because I want to focus on this, I'll put links to the reference to all of those resources and references of this video. So here, if I say mute, that means that I want to be able to modify whatever it is that I put in there, which is, so, and the reason for that is we have something called setdemands. Oops, where is it? Setdemands. And setdemands requires the self to be mutable, because when you get demands, you're kind of getting a read-only view into the own data, so it's a borrowed. But with setdemands, you can actually modify it, so that's why you need a mutable pointer reference, which implements this trait, and we don't know what the size of it is. That's why it's din, but we do know the size of what that is because it's a smart pointer. Okay. Whew. All right. So let's see. So now that was just basically the thing to store our components. And I just make some components like we normally do. And then we can now push them into our collection. So notice that when I push, I'm not pushing, oops, what the heck? I'm not pushing the button, I'm pushing immutable references to that button. So that's kind of like how this works. So here I can do now, I can make some assertions. I can say, oh, actually I can render them. So I can say, hey, look at that. It rendered a button and a label, because this is just a container which contains mutable references some type whose size we don't know that is guaranteed to implement the component trait with these two concrete generic type arguments. The inner storage type is dimens2D, and the rendered output type is string. So there you go. So now we can do other things, like we can now say assert EQ. We can get its dimens. They're both small because we set them to small, so yay. Then we can do something like we can access, actually this one, where is it? Do this. Here we did. What just happened? Iter mute. Oh, it consumed it. No? What am I doing? Nope. Actually, why is it doing iter mute? This is weird. Okay, that was more Copilot nonsense. Okay, so there you go. What is this saying? Oh, right, because actually, let me see. Cannot borrow button component as immutable because it is also borrowed at mutable. Oh. So to avoid stuff like this, you can do this. Essentially, just take out the confusion that might happen below. Ah, right. So I pushed it in the array. So what I could do is like this. Components one. Actually, they're both going to be small. So let's make this second one large. So this test has something to test. So even though, so when I created them, I can write code like this, no problem, because I haven't pushed these variables into this container, which collection, which takes ownership. Ownership of what? Of the mutable reference. So that's why I was not able to do this. Because it's saying, well, I've already moved button and label into components. Go get them from components because, you know, I don't have access to them anymore because these have been, you know, these have been moved. So this works. I can say, oh, get me the first thing that I put in, which is the button, and give me the, you know, second thing. And that's how we can disambiguate, you know, one from the other. Now the button component, notice that even though this is button 2D and this is labeled 2D, as far as this collection is concerned, they're both components. So this is called type erasure. So even though here, I know that, you know, button component is a button 2D, label component is a label 2D, and this is after type erasure. They both look to me as if they're components. So if I were to like coerce the button component to be a mutable reference of type button 2D and not of din component, then I have to downcast ref it, which is a thing. So, but I'm not gonna do that because the whole point of this is to be able to use polymorphism and rather than like take a more vague reference and make it more specific. I didn't want to say generic reference because generics mean something, but yeah, I guess more concrete and more abstract. I don't have very many good words for that. Okay, so now we can. So now that we have done that, we can also say for view in components. What the heck is it? Iter. Wow, it really wants this to be iter mute. Because it's a, we can access the components as if they're views, because this is, I'm saying access as component, and here I'm going to say, which is totally redundant because obviously anything that can be accessed as a component can be accessed as a view, as can be shown here. So if I run this, as you can see, it dumps the width and the height. This is the second print line. That was the first one. So now we can actually mutate them. So we can say set new dimensions on all the components which are also views in the collection. Finally, here where made Copilot happy, it got its chance to use iter mute, and here I can say, oh, it's 300, 150, 50. Oh, wow. Let's do this. Let's just make this a new type. So, I mean a constant. So we'll call this. Oh, wow, such descriptive names. So we can say const other dimens 2D and just paste that. Okay. So we just set them to be other, and then now I can say, I can basically pull out the components again, get their dimensions, and make sure that it's other. And this should work. Let's see. There you go. Wow. So that was a journey through the type system, because I didn't like the cat and the dog example. So I kind of can see why I did the cat and the dog example, because it fits in like a few lines of code. This doesn't. And also I decided, I don't know whether this is more confusing or not, but I decided to add a little bit of more generic flavor in here, just to kind of showcase that, oh, okay, if I have a view, so you can think of it this way. This is like inner storage. I don't know, this is a better word. And then here you can say this is inner storage, and this is render output. So the inner storage is like memory, where its dimensions are stored somewhere in something. And in our case, this is. I mean, really, we should have another trait called inner storage, which says get width, get height, get x, get y. But this was just kind of like, oh, okay, and inner storage is anything that has debug, copy, clone, and partially unique, which doesn't make that much sense. But it's kind of like there's one more level of complexity to be added to this example, but then these lines would become longer. But I really wanted to show the relationship between component and view and throw some extra confusion in there, just to kind of like keep things interesting. And this should, oops, what the heck? What was that? That should build and test. Yes, and you can always use bacon. Bacon is awesome. All right. Let's see. So that pretty much wraps up this live coding video. If you have any questions about this video, let me put this up here because my face is on the one of the monitors that has the articles on them. You can't see like this section of the video. Okay, so if you have questions, I disable comments on all my videos because sometimes some of the comments aren't very kind, and I can disable them, so I do. So please, if you need to ask any questions about this or any other of these videos, please feel free to connect on Discord. We have a newsletter. I don't really send too many of those out, less than one a month. You can sign up for that if you want, but definitely if you like the YouTube channel, please subscribe. And then, oh, also we have this the Rebel Open Core repo, which has tons and tons of real world examples with all of these patterns in it. So give that a look if you're interested to see how this is used in real world code. So with that, thank you for watching today's live coding video. Take care, and you will see me in the next one. Bye.